Quick Check 3.2 is talking about the idea of isomers. And isomers, we know that means iso means the same and mer means parts. So we can take the same parts and put them together different ways and actually get different molecules. An example would be pentane. So with pentane, here we have 5 carbons and 12 hydrogens. And that could be 5 in a row, or it could be 4 in a row with one coming off the side. Okay, and those either have the same formula, they're going to have different properties, and they have different names, because remember the name is based on the longest chain. So even though these are both isomers of pentane, this one is called pentane because it has 5 carbons in a row. This one's called butane because it has 4 with a methyl coming off the side, so methylbutane. So let's look at a couple of examples. First question here was to draw and name 3 isomers of C5H12. Well, we were actually just looking at the answer right above us. So one way would be to do 5 of these in a row. We'll come back and put the hydrogens on in a moment. Another way is to do 4 in a row and have one coming off the side. And the other one is to do 3 in a row and have one coming off this way and one coming off this way. So if we go back and put in our hydrogens, remember, our shortcut is just put in the sticks and leave off the H's. Okay, it makes it a little easier to look at. Okay, each of these would be C5H12, but this one here would be called pentane because it's 5 in a row. As we saw before, this one here is 4 in a row, so it's going to be called butane, and there's a methyl on it, so it's called methylbutane. And the methyl is hanging on carbon number 2, so it's going to be called 2-methylbutane. This one here, we have 3 in a row with 2 methyls hanging off of it, so this is going to be 2,2-dimethylpropane. So 3 in a row is propane, there's a methyl, so that's dimethyl, and they're both hooked on carbon number 2, so it's 2,2-dimethylpropane. Okay, we went 4 isomers of C3H6F2. I've drawn 4 backbones here, so here's the 3 carbons, and I have places on there for 8 atoms. Okay, 6 will be hydrogens, 2 will be fluorines. And we're just going to show the fluorines. So we could put them both on the first carbon, and that one's going to be called 1,1-difluoro. And 3 carbons would make it propane. So 1,1-difluoropropane. Now the difluoropropane is going to be the same for all of these. The only part that's going to be different are those numbers. So we could do a different one. We could put them on 2 and 2. So that'd be called 2,2-difluoropropane. We could put 1 and 2. So 1,2-difluoropropane. And we could put them on 1 and 3. 1,3-difluoropropane. Now, we could draw these differently, so we could say that if I put them, here I have it on the first one here, carbon 1 and carbon 1, okay, like this. If I put it here and here, that would also be 1,1. Okay, or if I did it over here, that would be called 1,1. So there'd be a lot of ways to draw it, but only that one idea, 1,1. So 1,1, 1,2, 1,3, and 2,2. Those are the 4 isomers of C3H6F. Okay, another one. Draw and name 2 isomers of pentene. Okay, pentene, that means there's 5 carbons, and we know we're going to have a double bond in there somewhere. So what we can do is just draw our 5 carbons, and we know they're going to be connected at least by 1 stick. But as pentene, one of these has a double bond, and so let's just put it here in the first place. And that one's going to be called 1-pentene. And then another thing, sorry, that should be 1-pentene, not comma, 1-pentene. Then the other thing we could do would be to put the double bond between the second and the third, and that would be called 2-pentene. We would not have a 3-pentene because a 3-pentene would really be a 2-pentene, numbering from the other side, and the same thing, a 4-pentene would be really the same as a 1-pentene. So these are the only 2 isomers of the pentene that would be called pentene. Now we could take these same atoms and maybe do 4 in a row with one coming off, and those would be isomers of pentene, but they wouldn't be called pentene. So we'll stick with these two. Now, one little piece of this is, where are the other hydrogens going to be on this? On this top molecule, we can see this first carbon already has 2 bonds, and each one can make 4 bonds, so we can still add 2 more hydrogens. On the second carbon, we have 1, 2, 3 bonds already taken up, so we can add 1 more. On the third, we've only used 2, so we can add 2 more. 2, we can add 2 more. 1, we can add 3 more. Now on the bottom one, okay, we have a carbon, 1 bond, so we have 3 more. Okay, 1, 2, 3, we can add 1 more. 1, 2, 3, we can add 1 more. 2, we can add 2 more. And for this 1, we can add 3 more. Now as a subtlety, here we had that double bond in the middle, and I put both of these hydrogens sticking down. We could do another isomer where one's sticking up. And so one of those would be cis and one of those would be trans. So there'd actually be a cis version and a trans version of 2-pentene. But we're not going to worry about that right now. Okay, name and draw and name 2 isomers of chloropropene. Chloropropene. So we know the propene means we can have 3 carbons. The propene, the ene part, means one of those is a double bond. And if that's a double bond, that means here this first carbon has 2, so we can add 2 more atoms, 2 more hydrogens. The second one has 3, we can put 1 more. Third one has 1, we can put 3 more. So that is our backbone. I'm just going to copy it over here. Now, where can we put a chlorine on here, and the rest will be hydrogens? Well, name 2 isomers of this. We could put a chlorine right here. Okay, we could put a chlorine on the second one. Okay, and it turns out there are other answers we could possibly do. So let's make room and do them. Turns out we could put a chlorine here on the third one, and we can actually put a chlorine down here in that bottom one. So here's what's happening. This first one here, okay, this first one we're going to call that 1. Now the numbering on this is kind of tricky. Where there's a double bond, the double bond defines where you're going to number. You're always going to number closest to the double bond. So on all of these, this one here is carbon number 1, the one on the left, because it's closest to the double bond. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And so this first one here is going to be 1 chloropropene. But you might notice this one down here is also 1 chloropropene. So let me finish the name. And the reason we can have 2 of these, it turns out one of these is cis and one of those is trans. Now to see the cis and the trans, I'm going to fill in where the hydrogens are. That makes it more obvious. And we can see with the hydrogens across from each other, okay, this one on the top here, this must be the trans. And this over here must be the cis. So cis 1 chlorobutene, trans 1 chlorobutene. That's a little subtlety. Okay, this up here, we'll call this guy 2 chloropropene. And there's no cis and trans involved because these 2 places here are the same, so there's no cis and trans. And the last one here is 3 chloropropene. So name and draw any 2 isomers of the chloropropene. Any 2 of those 4 would be great answers. And that's quick check 2.